As promised or threatened, pick your verb yesterday, I want to talk a little bit more about OSDF. I don't want you guys to take it just for me, so I'm going to try to spec my time. So make sure to give me a 10-minute warning, splitting half of this, myself talking a bit about the big picture, and then Fabio is going to talk for about half the time talking about a little more of the operational metrics, monitoring what he as the operator does to watch over the OSDF. So here's my big word salad of a sandwich trying to describe the OSDF from yesterday. So pick it apart, it federates data sets. So we think of these collections that we expose into this federation as data sets. Another component is disparate repositories. So these are all independently run data set repositories. In some cases, it's just a file system. We're working more and more to try to be able to enable, say, independent S3 instance. Another important aspect is this pulls it into a coherent namespace. So we try to have any two things that get delivered with the same name is the same object. And then I think the other really important part of this definition, since we've talked a lot about caches lately, is that we're referring to these things as objects inside. And yes, underlying these, so if you look at the pop open the hood and look at it, these are files in the file system. But we prefer to talk about them as objects for two reasons. One, we want to emphasize the fact that they're immutable. That really bad things happen in these sort of distributed cache-based systems. You start mutating things, and usually the word association with objects is much stronger toward immutability. And I want to emphasize that despite the D of the name, what we're really talking about is not data. We don't have any idea of what's inside. We're not looking at the headers and telling you what branches are in the root file. We are delivering you, at least at this point, a stream of bytes. So if we had the ability to go back in time and call it the Open Science Object Federation, well, it still would be unpronounceable, but it might be a little closer to the truth. A couple important things with the OSDF I'll talk a little bit today is to distinguish the fact that there's the data set provider, the thing where the data lives, and then the origin is the service that connects it to the outside world. The analogy here is think about the host of the CE. We don't mistakenly call Expanse and the CE. We say there's a cluster called Expanse, and then there's a CE that connects it to the world. And similarly, we want to make sure it's apparent that the origin is not the thing with the disks. The origin is the service that connects whatever the storage service is to the world. A little bit of this talk, I'm actually going to go through a couple places where we're trying to clean up our terminology and make things less ambiguous than they used to be. If you remember, for example, we used to call everything stash cache. So we had a RPM that was the stash cache cache. We had an RPM that was the stash cache origin, and we've committed many sins along these lines. So at least this is my attempt at penance. Where we use the OSDF mostly today is within the context of delivering objects for distributed high throughput computing. So this is a typical setup that you might see where we have an execution point, something that invokes a client that needs to pull in data. A lot of this picture runs the same if you're writing the outputs as well. The client contacts some sort of central or distributed central service, some sort of manager that provides some input or advice on how to find the data. So here I said this client must be somewhere around the Pacific Northwest, so it's going to this cache. If the cache doesn't have it, the cache has the ability to, again, to the manager to find the origin that serves up that particular piece of the namespace. And again, today our bread and butter actually is POSIX file systems. So I've here drawn a separate POSIX file system that the origin contacts. So the really important parts of the system are that form the OSDF itself. You have to think of the caches, the origins, the manager, and the client. And then of course, The idea is we tell dataset providers, hey, are you tired of trying to have to scale all on your own? Do you hate it when all of a sudden this clever scientist with access to 10,000 cores starts obliterating your system? And the goal is that all the dataset provider has to do is plug in one of these pieces, and they have the access to the common set of clients, to the scalability, to a common authorization with, and so forth. So long term, the way I think of this is a little bit more of this line, that we're building a transport bus. So we're building the thing in the middle that connects all sorts of different data set providers through, I almost think of this as, the old school adapter plugs when you go out for international travel. Do you need the POSIX adapter plug? Do you need the S3 adapter plug? Do you need the HTTP adapter plug? And this way, the dataset repositories, they don't care what clients you're using. And the clients, I'm hoping, don't care what's underneath and serving up those objects. I really think of this as kind of a generic layer that we can move back and forth within. And in fact, I think for us here, I even drew, the client as, or the OSPool client is just one way that we move this data about. And I think there's opportunities out there to maybe think beyond just kind of our traditional bread and butter. We've talked a couple times a little bit about how we do this in practice. You can go download the origin and run it all by yourself. But just like with the hosted CE, we usually nudge folks over to having a hosted solution for this. Of course, for us, it really matters whether or not the CE, or in this case, the origin, is nearby or not. So we typically try to co-locate the origin with the data source itself. So here, we typically do this through Kubernetes, and the person, he's either up here or over there, that's operating and making sure that the origin service is working. Again, getting to this terminology, I'd point out that we've been talking a lot about the OSPool lately, and I would claim that the OSPool is the flagship Condor system. Whenever we come up with a wonderful, great new idea, the first thing we do is feed it out to the OSPool. And terminology-wise, nobody seems to mistake the OSPool for Condor, right? That the OSPool is this thing, this service, this source of capacity, and then Condor is the software around it. However, we didn't follow our own advice along those lines with the OSDF. So as part of our penance, there's a software stack that leans, or that powers the OSDF, and we're trying to create the same separation. Forgive us, we're trying to tinker with logos, but the mental part is where, when we are referring to the software stack right now, we're going to try to call it Pelican. It's the same stuff. I didn't change all that much. It's, the origin, for example, if you peel back the layers, extra D's still there. But we want to be able to, in our discussion, talk about the software differently from the OSDF service. So going forward, talking about new adventures, you'll probably see some of these different names floating around. We have the Pelican software and the OSDF service. Along those lines, we're taking the software. You can get objects in the same way, mostly that you did before. We're working towards being able to start an origin itself for the software, so you don't have to learn two new things. Obviously, just like you have to configure the Condor client, you have to say which collector to talk to. If you run the Pelican client, you have to tell it which, what federation you want to talk to. Now, of course, I just hear somewhere in the back somebody is screaming, I just learned how to use stash CP. Why do you have a configuration file? So our our goal is to make this relatively painless for existing users. So if you actually rename the binary to the venerable /CP, it goes back to the exact same behavior. You don't have to, if you don't care that the fact that the software and the instance of the thing are two different things, you just want to not break your scripts, that's an option here as well. So as I promised, it shouldn't just be all the computer scientists waving his hands around. I want to have somebody come up from operations. So I'm going to hand it off to Fabio, who's going to talk about how he monitors and watches over things.
Okay, thank you so much. It's nice to see everyone. Sometimes I'm the first time seeing, not besides I'm see every day in Zoom, but I'm in person, like mode. And I want to talk about a little bit how is the Open Science Data Federation under the hood. Brian can show a little bit how the OSDF works, and I want to show a little bit about how it. Let me put my timer here because I lose my turn. Yeah. So, let's show a little bit how is the hardware, how you can deploy a new origin, and how complicated it is. It's a lie, very simple. I have a new bunch of new hardware, as you can see. I have hardware in San Diego, Boston, and other places. I have new origins and new caches. The origins normally you can know, but users can save some files over there. It's not a straightforward process right now, but you can send data. It's just a process to how to do it. It's not that complicated, and it's possible to use these caches to everyone. It's a very good, interesting. I have a new fancy site made by Derek. It's very interesting because you can see the amount of data read and send. You can see the origins where the origins and the caches where they are. This is a very interesting way to see. I just posted here. You can see the link. And you have the OSDF client, but it's not more OSDF client. It's another set of software. But the aim here is just show, because we say object storage, we say a lot of different things. But what is it? Basically, if you want to set up a new origin, using the whole process we are doing here is pretty straightforward. It's just have some hardware. We have ways to integrate this hardware in a Kubernetes cluster. And if you have everything, I can guarantee I can put an origin online in at least 6 hours or less, or your money back. And to access the information is very straightforward. We have a different tools, but the same aim. Literally just say which data we want and where to save, and it's done. All the objects and stuff in the end is just a storage with a lot of space in a POSIX system, not a Linux, anything else. If you want to share the data and you don't need to change anything, it's literally a file system. Of course, we have the raw X3D solving all the problems to share and distribute the data. But in the end, if you want to start, it's just a POSIX storage. We have storage now with new projects covering all over the US. Everything is online besides Houston, but it's on the way. And you have access to all these caches. When you register your origin, you can access the information using any of these caches. And the own tool, the OSDF client or the other tools related to OSDF can find the nearest cache. That's a very interesting thing, because you could be in anywhere on the US or even in the world, and you just ask a file, and the OSDF is going to find where can reach this file closest to you. It's a very interesting thing, and it's a very straightforward way to do it. You just ask the file, and the file is going to be there. We have caches, new caches, and new origins. I know you guys saw this picture, but it's very interesting because we have a lot of caches and origins on UCSD, a lot of others close to New York, and others in the middle of the country. And it's very easy to locate information. Besides, we have caches a little in Europe. We have a new caches coming up on Amsterdam, London, and we're going to cover some spots there. And we have a new cache going to Singapore. Then we cover a little bit of Asia with more information provided by the OSDF. We're monitoring everything. Literally, we have different strings from X3D to figure out if the cache amount of the hits or the misses of the cache, if the origin is working, if the cache is working, we have a lot of information. This is just a graph showing the amount of entries we have to the information. Each one of these is just saying, okay, you transfer a file, you copy a file, you can literally check everything to happen. It's not that wonderful to the users, but for other administrators, I can literally help and say, okay, what's wrong? I can look in the logs, the caches, I can look at the monitor system, I can check what's going on. And besides the fine-grained monitoring, so directly on XRootD, I have other services checking all the caches and out origins. Not everything, because I have some caches and origins we not control directly, but most of the caches and origins, I have a system to literally say, okay, you are a cache, can reach, we write a file on the origin, we ask for the cache to fetch this file, check if the file is okay, and delete the file in the origin. With that, you can literally check if the Open Science Data Federation is working or not. And sometimes you can prevent a lot of problems related to a job is not running or something related to that, because you test all the Open Science Federation all the time. This is just an example what you have. Don't try to understand all of it right now. But it's basically saying the hits and the misses on a specific cache. If you had a lot of misses on a cache, maybe it's just warming up the cache, or there's a problem there. Then you can literally check. That's one of the several dashboards we have, and you can control it. And we have another ways to visualization the Open Science Data Federation. This is just a simple matrix with a correlation between the cache and origins and the latency. Then you can monitor the network and the performance between caches and origins. And you have another tool to check these two, to check literally if a cache wants to talk to origin, how fast it can be. And that's it.